Hello, welcome to the video. In this video, we're going to go over how to get started coding in the TWS API in native C++ using a Windows system. In the previous video, I showed you guys how to set up a compiler on your system and how to set up an entire development environment, including batch files for compiling these programs. So if you haven't watched that video, you should watch that one if you really have no idea how to even compile a program. In this video, we're going to be looking at some of the methods to interact directly with the front end of the Trader Workstation software by interactive brokers. And I'm going to go over the code step by step with you guys and try to simplify it so that even someone without coding experience can start to understand how these things sort of work. And you can use this if you want to develop your own applications to access market data from the Trader Workstation and also place orders, manage orders, and basically do things that are not natively supported in TWS, but you can kind of code your own solutions to do stuff. If you don't like problem solving and if you don't like troubleshooting, then I don't recommend you do this. But if you are a programmer and you want to learn how to code in the TWS API, I think this video can help you get across some of the common pitfalls. It's not really an interface where everything is sort of streamlined and ready to access. Because C++ is a low-level language, we have to be very considerate about how we are accessing some of the data and manipulating it and then using it in our program. So let's get started. In this video, I'm going to show you guys how to subscribe to position updates. I'm going to show you how to request market data, subscribe to an option contract, and I'm going to show you how to get an entire options chain from TWS and subscribe to market data, real-time updates for the entire options chain. You'll have access to all of them. And I did this all myself. So let's get to it right now. And if you want to support this content, it's very simple. You click on the link, the first link, interactivebrokers.com. It'll take you right to their website. It's a great website. It's a fast website, and that's why I like it. And I work with them because I have a lot of tutorials on TWS, and eventually they reached out to me and said, hey, we want to sponsor your content. This video is not sponsored. No one paid me to make it, but we do have an affiliate relationship, okay? So thank you for watching. If you want to support it, click the link. Okay, so the first thing you need is TWS to be running on your system. I'm running TWS here in the paper trading account. And when you are developing stuff, you should absolutely always be using the paper trading account. And it's exactly the same as the live account. The only thing that is different is regarding how orders are filled because it's a simulated trading service compared to a live trading service. I do have a few videos that explain those differences as well. You can check those out. And we are going to go over to global configuration and then API settings. And here in the API settings, we've enabled ActiveX and socket clients. This has to be enabled. And then our read-only API is disabled. And this is important for some of the EWrapper callbacks. Today, we're going to be showing how to request position data. So this needs to be off. If you do any kind of order placement, requesting orders or placing orders, this definitely needs to be off as well. Then the socket port here is configured to the port that your program is using. In your code, when you're calling EClient, eConnect, you need to make sure you're connecting to the socket port that you've configured in the instance of TWS that you have open on your system. In this case, that's the port we're using. Now that we're good on TWS, we'll just leave it running here. And in today's example, we're going to be using the symbol Apple, and we're going to be requesting options contract data for the options chain of Apple, okay? So let's go over to our source code. And I'm also going to open up my compiler, which is just a command line. So I'm just going to type CMD to open a command line. And in order to compile my TWS program today, all I need to do is type in TWS because my batch file is already configured and it's accessible in the default path here on my system. And I'm going to show you what that batch file looks like. It's right here. And today we've configured our source code file to be this one, YouTube1. And that's the source code we will be compiling today to show some of the examples. And that is right over here. Okay, so now that we have the source code here, I'm gonna step you guys through it one step at a time. And I wanna explain to you how I got some of this source code. So it's actually a combination of two of the existing examples that come from the Jan Boonen C++ library that we are using here. So I'll just show you, I'll go over to Firefox. This is the GitHub repository, Jan Boonen TWS API C++. This is the first example called retrieve history. So we've used this as a basis, and then what I've done is copy pasted some of the EWrapper callback functions, like wherever you see virtual void, those are the EWrapper callbacks. And these are the things that you can choose which callback functions you want to include in your program. So I've included the ones that I will be using today. For example, connection open and connection closed. This is important because TWS is going to let our program know when there is a connection open and when the connection has been closed. So let's go over to my program and we'll step through the code one step at a time. So at the top, we have our includes and our header files. So the first thing is we're including the necessary header files to get code from the library. Then I'm including boost format. This is optional, but I use boost format for some debugging purposes. So I'll show you how to use it a little bit later in the video. Algorithm is for organizing a vector that I will be showing you guys later in the video. And I'm using namespace TWS API for the EWrapper callbacks and also the EClient methods. And then here's some additional definitions for if we are compiling on a Windows system. Most of this is fine. The sleep function here is useful if you need to pause the code to debug stuff. So let's continue. Then we have our EWrapper class. And this is where you put all the callback functions. So I'm going to simplify this as much as possible. So what these basically are is depending on which EClient methods we're calling to TWS. Let's say we're calling connect to TWS, we're calling request market data, we're calling request position updates. It's going to be filled in one of these EWrapper methods right here. So for example, I'll just scroll through them just to give you an example here. Virtual void. Whenever you see this virtual void, that defines one of the EWrapper callback methods. So in this case, we have position. So when you subscribe to position updates, it's going to provide data into this callback function, and then you can check that data here and manipulate the data any which way. And then in the main scope of your program, I know I'm going through this fast, but I'm giving you guys examples here. Once you've manipulated the data from the EWrapper methods, you can then access that data in the main scope of your program. So just as an example here, I'll scroll all the way down to where we have the while loop, which is an endless while loop here that just calls check messages from the TWS. So it's just checking messages from the TWS. Is there any messages that TWS is sending to us into our EWrapper callbacks? And if there are, it's going to print them because we're checking messages. Basically, after you've run the program, your program pretty much lives inside of this while loop. And then in order to access data from the EWrapper callbacks, you're going to have to make reference to them like this. For example, I'm making reference to one of the variables inside of the EWrapper class called rec4, and I'm accessing it like this, EWrapper.rec4, and I'm checking if it's equal to 1. All right, so let's go over some simple stuff to start. The first thing we're going to show is subscribing to position updates. So we're going to be using this EWrapper callback right here. I'm just going to comment this out, and then I'll explain to you what it's doing after. I'm going to uncomment it. So let's go over to the main scope of our program, where we have right here int main void, we have our EClient, and then we have our EWrapper. So I know a lot of it's commented out, but this is where we're connecting to TWS. We have EClient, eConnect to the port. All right. Now here we have some of these EClient methods that we can choose what we want to be subscribing to. So if I call EClient rec positions like that, it's telling TWS that I want to request position updates. And when TWS gets this message, it's going to be throwing those position updates for my account into this EWrapper callback up here called position. All right. And this callback returns these variables right here. It returns the trading account for the position. It returns the contract for the position. And this is a structure where we can access multiple variables from the contract structure. We also have the position, which is just the position quantity. And then we have the average cost of the position. So let's go back down to our code here. We're not going to be doing anything else right now. You can see that we have this contract definition. I'm going to comment this out for now because we do not need this. Okay, so I just have to comment out a couple of the things. So we'll compile this program, and all we're doing is going to be, and we're just going to be subscribing to position updates. So here's our program. And what I'm going to do now is just select the symbol Apple on my TWS and put in an order. Okay, so I just bought 30 shares of Apple. And you can see that nothing went through. The reason nothing went through is because we're not printing out anything in the EWrapper function. So now I'll show you how to do that. So now let's go up to the EWrapper callback method. where we had this block of code here. So the first thing it's checking is the contract structure. So we're checking contract.symbol, and we're saying if the contract symbol is not equal to USD, and the contract symbol is not equal to EUR, and the contract symbol is not equal to CAD, then it goes ahead and checks the next thing. And what this basically means is I don't want to be including any Forex positions, because TWS was sending me Forex positions and I did not know how to turn that off. So the first thing we're doing here is we have a variable we've declared in our EWrapper, and we're calling it my position, and we're initializing it to 0. As soon as this callback gets triggered, meaning as soon as TWS sends us the message, my position is getting set to position. Now, in practice, this is not what you should be doing, because before saving position into a position variable, you also want to know what the contract is that you're saving the position for. So in this case, this is just a simple example. And then we're just checking here if our position is not equal to 0, meaning that there is a position. What we do is we remember the symbol of the position. In this case, what I'm doing for position symbol is I'm just setting it to AAPL, but actually what this should be is contract.symbol. So it should be if position is not equal to 0, position symbol gets set to contract.symbol. And if you look at my comments here, basically what I would do with this is I would have an array or multiple arrays that are saving the position quantity along with the symbols that go along with those quantities in order to be accessed later in the code. Right now, all we're doing is we're setting position symbol to be AAPL, and then we're setting my position to be the quantity of the position being returned from the EWrapper callback function. And then there's an else here that says if the position is closed, meaning that my position is now equal to 0, because that is what the EWrapper callback function has now told it. And then what it does is it goes ahead and forgets whatever string was in the position symbol variable, okay? And then the last thing we're doing here is we've just constructed a boost format function to print out some of these variables. So we're getting the account, which is one of the variables there. Then we're printing out position symbol. We want to know what symbol our position is on. And then we're printing out what the position quantity is. And we can print out other things too. Like, for example, if we go over to our contract.h file, we can see all of the members of the contract struct. So we could print out any of these basically, because it's returning a contract struct every time there is a position update. And if we wanted, we could also print out the variables directly coming from the EWrapper callback. But in this case, I've initialized them to other variables because I want to save them outside of the function. So now that I've uncommented that, let's go ahead and compile the program again. I'll close that. Normally it should close by itself. Okay, so now we have it right there. So we have our first position update. As soon as our program is run, we have our account number, we have our symbol, and we have our position, which is 30 shares in TWS. So right now I'm going to sell 10 shares. I'll transmit it, see how fast it can fill. Okay, it's filled. Now I have sold 10 shares. My position quantity is 20. And you can see it does submit multiple updates. This is an issue and you can't really control this, but it does submit duplicate updates, sometimes triple updates like that. And now what I'm going to go ahead and do is close the position. I've now closed the position and we can see position is 0. So we're subscribing to position updates. That's what we've done right here. Okay, and that's all that is required for that. Okay, the next thing we're going to show here is subscribing to real-time data for an options symbol and accessing all of the data for an options contract. And then after that, I will show you how to subscribe to multiple options contracts and actually the entire options chain for a stock if you want. So let's go back to our main function, and I'll just comment out rec positions because I don't want to subscribe to position data anymore. So what we're going to need to start is a contract definition for what symbol we want to subscribe to. And this is in the main function right after it's connected to TWS, but before it goes to the stage of check messages in a loop. And then with the other example at the end, you're going to see how one of the members of the contract structure is getting set inside of the check messages loop, but it's being handled very carefully in a clever way. So let's get on with this. So I'm going to uncomment this contract definition and I'll explain it to you. So we're creating a contract structure with the name C. Now the program already knows what a contract structure is because it's already including the header file up here. Those header files know that when you declare contract, it's referring to a contract structure like in this header file, contract.h. So we need to specify some of the members of the contract structure. So we're specifying the symbol. We're specifying the security type. In this case, we want to get an option. We're specifying what kind of option, a call or a put, and I do recommend choosing either call or put, or just making these into two separate contract structures if you plan on calling both the calls and the puts. In this case, we're just going to just get the calls. Then you put the expiry date for the contract. Then you have to put the currency for the contract, and then you put the exchange for the contract. So we're just defining our contract, and then you can set the strike price for the contract. Now for this example, I'm just gonna subscribe to one options contract, and then I wanna explain to you why this is obviously not practical. You probably already understand that this is not that practical. It doesn't make sense to type in the strike price here every single time. Again, this is just for testing purposes, and then I'm gonna show you a method of getting all the options contracts and making sure that you're subscribing to the right strike prices. So then what we're doing once we've declared our contract structure is we're simply calling EClient request market data for the ticker ID, which is 0 in this case. For the contract C, this is the third argument, which is fine to leave it as an empty string. And then the last argument is set to false. So just before we compile this, let's see here. So we'll just set the expiry to 2023-02-17. And before we compile this, I want to show you the EWrapper function that's going to be providing us with the option data live streaming, which is this one right here, tick option computation. And you can see here, this one provides a lot of variables to it. And you can see I'm using boost format to enumerate those variables without having to specify what type they are every time. Most of them are doubles, but again, it's just helpful. You can see here, so we are going to be seeing the ticker ID that we specified for the request market data call. And then it's going to show basically all the tick types that are supported for this option. I think there's 4 different types, and you'll see them as they get printed to the log. You'll see the underlying price, you'll see the implied volatility, you'll see the price of the option, and then the 4 Greeks. And we're only going to see this for one contract right now. Okay, so I'll go ahead and compile the program, TWS, and let's see what happens. Okay, so we see connection open and connection closed. So what that tells me is that there was a problem. So whenever you see this, connection opened, connection closed, it tells you there's an error with the contract definition, most probably, that you're trying to subscribe to. So for now, what I'm going to do is go back down to the contract definition, and I'm going to change the expiry date, because I noticed there's sometimes some issues with this. So I'm going to change it to 2023, February 24th. And hopefully that works. Let's compile that. And this is a valid expiry. And you can already see how there's issues. If you make a request to a non-valid contract, then there's problems there. So here we have an options contract now live streaming. So we have our ticker ID 5, and you can see every time it's a different tick type. You have the last price, the ask, bid, if there's an update there, or model, which is an update to, I think, the implied volatility. And there you have it, guys. Live streaming data for one option contract. Now let's do it for the entire options chain. You think we can do this? So let's just close this for now. We'll just minimize it. It doesn't really matter. And I'll close that as well. And I'm going to comment this out. And what we're going to be using for this method now is the request contract details. Now, it took me a bit of time to figure this one out for you guys, but I made sure to figure it out so that way it could be a reasonable reference for anyone looking about how to do this in the future. So we have our contract details EWrapper callback right here. Now, this was tricky because when it was making the request to get the contract details, I put a print statement here and it wasn't returning anything. So what I did instead was I debugged this using the while loop at the bottom of the program and using a vector. So this is the way that I'm using to subscribe to every single options contract that I choose, basically. In this case, we're just choosing one expiry date, but we've specified a number of strikes to subscribe to, and I'll show you how I'm doing that. So the first thing is here, I've created a vector of type double, and it's called strikes. And as soon as this callback function gets triggered, we're declaring a contract struct, and we're setting it to contract details.summary. And what that is, I'll show you. If you go over to the contract header file, contract details. Okay, so what that is it's a member of the contract details struct. And with this, we are getting a contract struct out of this contract details response that it's giving us. And we're storing it into this contract struct named C. Okay, and then what we're doing is we're checking two things. So we'll go slowly here. We're first checking the strike member of the contract structure. And we're checking if it's not 0, because I don't want to get a strike price that's 0. But again, this is just for debugging and it might not be necessary. Then we have rec4 is equal to 0. Now what rec4 is, it takes place inside of this EWrapper callback. And this EWrapper callback is returned when it is finished getting the contract. The way that I'm checking if it got the contract details, I'm providing it with the request ID that was used for the request contract details call that I'm making in the code. In this case, I'm using an ID of 4, and you'll see that as we go down further in the code. So I created a variable inside of the EWrapper class called rec4, and I'm just setting it to 0. And then inside of the contract details end callback, which is only going to get triggered when it is finished returning rec contract details. It's going to return that every time it finishes returning contract details. I'm looking for the request ID of my rec contract details call. So it looks to see if the rec ID from the contract details end is 4, because that's the one that I'm checking for in this case. And when you're using multiple requests, you're going to have to organize them one by one like that. So I'm looking for rec ID 4. If it's rec ID 4, then what I'm doing is I'm setting the rec4 integer to 1, meaning that it is now finished getting the contract details. And then just a simple printf statement saying contract details end. And while rec4 is equal to 0, meaning that it's not done retrieving the contract details request, what it's doing is it's storing all of the strike prices, all of the option contracts into my vector here, vector strikes. So basically what you end up with is a vector that has all of the options strike prices and basically all the options contracts that you've requested. If you don't specify an expiry date, you can get all the options contracts in that one request. So we'll show how to do that. The only way that I was able to ensure that we were getting this is by debugging the code further down. I'm not going to show you all the debugging procedures I used, but I'm just showing you what is working right now to get all this. Okay, so we're going to scroll down back to the main entry of the program. So I've uncommented this right here, which is another contract definition, and it looks pretty similar to the other one. And what we're doing with this contract structure is at the end of it, we're calling EClient request contract details for this contract, and that's where we're providing the ID for in this case. So the ID that you provide it with here is the ID that you're going to have to check for in contract details. And by the way, smash that like button if this video is helping you. So the problem we had to solve, and the reason why you can't just create a random loop and iterate through a list of strike prices, is because of the fact that if you make a request to an invalid strike price or an invalid expiry, then it breaks the whole program and your request will not go through. So that's why we have to use request contract details to make sure that when we call rec market data, we're requesting contract details for valid options contracts that have valid expiries and valid strike prices. So that's why we're using the rec contract details call. And now what we had to do is we had to code some logic to organize the vector and only subscribe to, say, a certain amount of strike prices, because maybe you don't want all of them. When you're requesting contract details like this, it's basically going to get all the call options for this expiry. But you may not need all the call options because most of them are like out of the money strike prices that nobody's trading. So for this example, I'm going to get only 20, and I'll show you how you can adjust that. And they're going to be the closest strike prices to the last traded price in this case. So 155, let's say. That's kind of where it's trading. 154, that's where Apple's trading right now. All right, so let's go on. And again, here's an example of a for loop you can create. You can say, okay, number of strikes is equal to 20. And then you can iterate through that, and then you can declare your strike price and just tell it what strike price you want to start at. But the problem with this is that, let's say there's like in between strike prices, like 152.5 or 157.5. If you're calling strikes one after another, you're eventually going to reach one of those in between strikes and it's going to bomb out your program. So that's why this method is invalid. You can't just use a simple for loop. We have to create some more complex logic. So let's go on and look at what we have. So we have another vector here, and this is actually a vector of pairs, a pair of doubles. The first variable in the pair, it's going to be the difference between our underlying price, which I've just set it in this case, but actually you should get this using another call to rec market data, get the last price of the symbol, and then pass it that way to the code we're about to show. But in this case, I just used underlying price 155 just as an example, but I'm just letting you guys know for that reason. So basically the problem we need to solve is we want to subscribe to options data for valid strike prices. So they need to be valid. And since we've already gotten all our strike prices through our rec contract details, we know that our strike prices are valid. So now what we need to do is we need to call request market data for our strike prices in some sort of a loop. But the problem is, let's say you don't want to subscribe to every single strike price. Let's say you only want to subscribe to like 10 or 20 strike prices that are closest from the current trading price of the market. So let's go over this logic for how this is all happening here. So the first thing is, again, a couple variables at the top, and this vector here is a vector of a pair of doubles. I know it's a little complex, but we'll get to it here in a minute. The first thing that's being done when rec options is equal to 0, which it is, and I guess we'll cover that first. What this basically is right here, rec options is equal to 0. I've initialized it to 0, but at the very end of this if statement, when it's finished, it gets set to 1. And basically it means only make the request once, and then don't execute this block after that. You can see there's these for loops here that are going to be used for calling rec market data and all that. We only want this block of code to execute once, and that's the purpose of the rec options variable. So if it's equal to 0, it executes it at the end of the block, sets it to 1, and then every single time this while loop gets triggered, it just skips over that and it doesn't execute it at all. Okay, the next thing we're doing is we're calculating the absolute difference between this value, which is the last traded price of the market, and each element in our vector. So we're comparing the strike prices in our vector to the last traded price of the market. And we're calculating what's the difference between them. And that's what this double variable is. And that's what this line is doing. The std abs here, when we're subtracting strike by underlying price, it's making it an absolute value. So it's basically getting rid of any negative numbers. So we're just getting absolute differences between the strike and the underlying price, making it simpler for subtracting the strike price by the underlying price. All right. So now I'll just simplify what this is doing right here as an example on the options chain. Right after it calculates strike minus underlying price. So let's say our underlying price is 155 in this example. It's saying 150 minus 155 absolute value is a difference of 5. Even though that would be minus 5. So what it does is it now pushes back two things into our new vector. The first thing is it pushes in the difference. So it'll push in a value of 5 because the difference between our strike price and our underlying price is 5. So the first value in the pair will be 5. And then the second value in the pair will be the value of the strike price. It will be that 150. So that's what our vector will look like. And it's doing that for the entire vector of however many options contracts that you decided to request details for. I hope we got through that. Then the next thing is we are now sorting the new vector by the difference value from lowest to highest. And the sort function here, it works on only the first variable of the pair. So we're actually sorting it by the difference. So we're going to get a sorted vector where the first few numbers in the vector, the first however many numbers you choose to iterate through, are going to be the ones that are closest to that 155. And that's what this is doing right here. So we have another vector yet again. After we've sorted the difference vector, we're declaring another vector called closest numbers. And this is the vector that is going to save the amount of strike prices that you want to subscribe to. So in this case, I've chosen 20. So I did the classic for loop, int I equals 0, I is less than 20, I plus plus. So we're creating 20 iterations, and for those 20 iterations, so we're pushing into this new vector the first 20 elements of the sorted differences vector. Dot second means we're pushing in the value of the strike price. We're not pushing in the difference value anymore because we don't need it anymore. We're just pushing in the value of the strike price, which is a second variable in the pair of that vector. So now this vector has the 20 closest strike prices to 155. Now that we have those, this is what we're doing down here. These are just debugging statements. I'll comment them out for now because we don't need them. We have a ticker ID, which again, I still have to work on ticker ID stuff, but I just set it to 30 in this case. And you need to increment it because you're requesting market data for each ticker ID. Because every time you request market data, it needs a unique ticker ID. And then all we're doing with this new for loop is we're iterating through the size of the closest underscore numbers vector. And before we're calling rec market data, we're initializing the strike price of our contract structure. Remember, our contract structure is still here. We are initializing that to the current element in the vector. And then we're calling request market data on the contract C. And then we're incrementing ticker ID for the next call to rec market data. And this for loop is going to be triggered based on the size of this vector right here. So if we set it to 25, we would now only request market data for 25 contracts. And this is where you can choose. You could say, I want to subscribe to all of them. I want to subscribe to only 5 of them. And that's it. So let's say we want to subscribe to only 10, for example. And the market just closed. So unfortunately, I think we're a little bit too late on this. Okay, so the market is opened again, and I do want to show you some examples of live streaming data. However, this also works when the market is closed. You just have to understand that you're not going to be getting live updates. So I made an error in my code when I was recording the video, and I had changed this operator by accident. So I changed it back now so that it's going to work correctly. Okay, so I've uncommented my print statement here in the tick option computation EWrapper function. And this is where I'm printing to the log all of the options quotes, basically the live quotes coming from the data feed. And of course, you do have to be subscribed to real-time data for the options contracts. I'm just subscribed to level 1 top of book data with Interactive Brokers. So I did change one thing, and I did specify an expiry date because I was having trouble retrieving them. So, okay, we did get that print statement. We get the vector size 78, and that's good. So now what I'll do is I'm going to uncomment the request market data statement just to show you how we can request market data. And I'm going to request market data for 20 contracts, closest to a price of 155. Now, currently, Apple's trading at a price of 151, but that should not be a problem. Let's go ahead and compile this again. We should be retrieving live updates for 20 contracts at this point. Okay, so we have this vector size 78, and so far we don't see any live updates. Okay, there they are. And the reason why they came in delayed is because I put in a sleep function at the bottom of the program. So it sleeps for 10 seconds before providing us the quotes. And that's just the way I've done it now for debugging purposes. So we are currently subscribed to 20 different ticker IDs, though it's possible that some of them are not actually giving us any updates because there's no activity on those options right now. So in those cases, we wouldn't actually be getting updates for those. As you can see, sometimes there's updates for certain ones, other times not. I want to show you another example of printing out the entire vector to the log. So what I'll actually do is I will print out the 20 closest numbers, or whichever the closest numbers are. So I'll do 20 in this case, and you'll see which strikes get printed to our log, basically which strike prices we are retrieving. And you can also check this when you're getting the live data, but here we are right now. So I've printed them all to the same line. So the 20 closest numbers to 155 are these ones. So we have 155 itself because the difference is 0. And then we have all the other strike prices. So we'd be basically retrieving data for all these strike prices because we've chosen to retrieve 20 different strikes. I'm still running into issues when I comment out the expiry completely. So I still have to work on that regarding retrieving the entire options chain when you don't specify an expiry. So I'll let you know what I come up with, and I'll see you in the next video. Thank you for watching, guys. Click on this video to watch more content. Click on this playlist to watch more awesome content. And thank you for watching. Take care.